As we learned last time how Newton's came out with the brilliant idea of finding the relation between the force, the mass, and the acceleration, as we are taking problems to solve using Newton's second law, today we will talk about these systems that Newton's second law can solve. Some of them are simple, some of them are intermediate, some of them are complicated. We will try to find for you the simplest examples to let you get the idea in its easiest and simplest form. We will start with the first system when we have two-body system. We mentioned last time when you say a system as you're talking about the equations of motion and Newton's laws of motion. We start with the two-body system. A system means many objects following the same physical parameters in terms of Newton's laws and equations. We talked last time about the canoe. There's two people pushing this canoe over the river, and we said they are all one system. You need to find the total mass for the person A and person B and the canoe. So that's the mass of the system. Then you need to find the acceleration of the system, and you need to find the force applied on that system. So you don't treat each object independently because they are all one system, having same speed and same force being applied on them, and they have the same mass. Here we have the two-body system. In many cases can be simplified as having two boxes connected together with a rope, and there is a rope that you can pull those two boxes with. So when you pull those two boxes, they are on the same floor. Each box has a certain weight or a certain force, gravitational force in this case. When you pull these two boxes, they will move in a certain speed, similar speed, like the whole system will be having the same speed going in a certain direction. Either you push it to the left or you pull it to the right, as in this example. Let's learn how to solve a two-body system through an example. You have two blocks. They have identical material connected by a light rope. In this case, we ignore the weight of the rope. They are on a level common surface, which is this surface. We assume the surface roughness is the same and the friction is the same along the surface. We have a force being applied as a pulling force to it of 55 newtons to the right. It is causing the blocks to accelerate. While in motion, the magnitude of the force of friction on the block system is 44.1 newtons. As you pull or drag these boxes to the right, they have acceleration of, they are being applied on them with a force of 55 newtons to the right, but there's a friction being generated on those two boxes or on the whole system. The problem is telling you that the friction force on the whole system is 44.1 newtons. Calculate the acceleration of the blocks. So we have M, or the mass for block A, 20 kilograms. The mass for block B is 10 kilograms. We have the applied force F equal 55 newtons to the right. You have the friction force of 44.1 newtons to the left. Always, as you already know by now, the friction force is always on the opposite direction of the applied force or the external force. What he need you to find the acceleration of this system. So what we analyze, we find the mass of the system, or the total mass, in this case equals MA plus MB. 20 plus 10 would give you 30 kilograms. Then of course you start with a free body diagram. You know the vertical direction, there is no motion, all the motion is in the horizontal direction. So the F net vertical equals 0 newtons. So we can say here F net horizontal equals the F plus the F friction. Vertical force F normal plus Fg would equal 0. Now our free body diagram, we start with the center of the box. We represented the two boxes with one box have a total mass of 30 kilograms. And you have the friction force to the left, and you have the applied force to the right, normal force going up, gravitational force down. Then if you draw the forces, you can find your F net horizontal going to the right. Now we replace the F net horizontal with the M total multiplied by the acceleration of the system equals the applied force plus the friction force. Rearrange the equation. You have the applied force plus the friction force over the total mass. That would be 55 Newton plus minus 44.1 Newton over 30 kilograms. That would give you acceleration for the system of 0.36 meters per second squared to the right.